Excuse me. Okay. So the point of discussion, the thing with which we are moving at this moment is ED, exploratory data analysis. And it is kind of, you can say that, the application part of whatsoever we have learned, right? So, you know, whatsoever we have learned was science, data science, you can say that this is applied data science. Okay. So data analysis, more or less, is data analysis, what we are looking into, right? Yeah, there's a problem with my spec. No worries, we'll see it afterwards. Okay, so applied data science. So the point is EDA, exploratory data analysis, right? If you more or less is data analysis, the Python libraries, the basic Python, whatsoever we have covered so far, right? All those libraries, visualization libraries as well. So if you want to see EDA, exploratory data analysis, exploratory data analysis, that again the same. If you can see the definition, analyzing data set to summarize the main characteristics, right or not, right? So don't worry about the word exploratory. Exploratory is like exploring. You're just not you're also finding the trend. So for this, I'm going to take a toy data set, very famous Titanic data set, right? If you're into the Kaggle and all, so I'm talking about this. So I've taken from this Titanic data set, right? Taken from this only. See whether I'm signing, okay, with this ID or not. So this data set I'm talking of, right? So this is a toy data set, built around the Titanic, the ship, which was caught drawn there in 1912. There was a movie also over it. James Cameron, who was a Leonardo DiCaprio, right? So the same data set. And based on that, we'll try to figure out, there is a survive column and passenger class. We'll try to figure out the relationship between the different columns and we'll deep dive into it, right? No worries. So there is no bar around it. So this data set I'm sharing with you. Um, you can take it from the Kaggle, of course, as well. And but I've downloaded it, so I'm sharing the same. Uh, just a minute. This actually it goes with like that in alphabetical order. The downloaded files. Okay, so guys, let me know if you got that train and test file, CSV file in your DM, right? In your chat box. So I've shared them. And the same I would use here as well. Like, you know, with a curiosity, like a person should go for with this data, and this is actually uh, be the right way to go around it. This is a toy data set, is not take it as actual data set, but just to learn these tools, just to learn the apply data science. We have many toy data sets likewise, right? But it looks somewhat similar. Let me import the dependencies, pandas, numpy as np. In fact, Seaborn also has Titanic dataset. Seaborn GitHub, Git repo, Seaborn. There was there. See, it is also a Titanic dataset, right? Seaborn library also have itself has Titanic dataset. Okay, guys, we move around it. Let's read the dataset. Let me know if you also got the dataset, able to put it over your environment, and able to read it. So this is a dataset. 891 rows. If you want to see the columns, these are the columns, right? Wow. Passenger ID, survived passenger class, name, sex, age. This is sibling spouse. This is parent child, ticket, fare, cabin, embark. We'll go each of them one by one, right? And but I believe you are able to come to the same as well, right, folks? Okay. We all are on the same page. Give me a thumbs up if you're able to read the data set. If I ask you, okay, the basic question, what do you think the most important column here, right? Just as a newbie, just as a you know noob, naive guess, or right, what should be the important column? Which column should be your if you would create a AI model or something, any model, what should be your output column? Target column. There is another term in machine learning for this. Well, should predict. This is the case. So target column is like the output column, which your machine or model should predict. If you have a AI agent, or say for example, if you have AI should predict with what? Which column? Yeah, can you DM me? So I'll just put few columns only so that you can see it. Yeah, folks, let me know. I need your participation here. Do you want your model to predict passenger class, or is just an information or fact? Do you want your model to predict the gender in this case? Maybe in some case you want to predict gender, this, but it's a fact only, right? You want to predict survived, whether this guy would survive or not, based on various features. I'll come to them one by one. But can you feel it? If feel it, give me a thumbs up. Survive can be your target column, right or not? For the time being. Then I'll come to EDA. Why, where we do EDA, or why we do EDA, why we're learning it. But just seeing this data set, I believe you all can read this data set. This data set can make sense somewhat. If not, we'll make it more sense. Slowly, we'll go to each column. Then it will make more sense. But I believe this is a mostly things are factual things. Passenger ID, passenger class, name, sibling, how many sibling, parent, ticket, fare price, what was the cabin, where does they embark as in stations, where they just boarded into the ship. So there must be three station, I believe. Southampton, Carol. Okay, you can check it. You can go to the Titanic Wikipedia. Titanic as in not the movie, but I believe, yeah. So there must have been the three uh, Southampton as for Southampton. So Southampton, I know there was, if you can see, embark SC Chernobyl, not Chernobyl, Kubog, I believe there was, right. So there were three stations. Why I'm going to the Wikipedia. I can ask the AI also. But you got my point, right? Cuborg, S Southampton, this represent this. Queenstown. Q is for Queentown. 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 S for Southampton. C for Cherbourg. Cherbourg, Southampton, Queenstown. Right. So these were the three stations. So data set makes sense, right? And now we'll try to get into the nerve of the data and try to, get some analysis which you can sell actually, right? Data is just simple only, right? The analytical part is like where the magic happens, where you can sell. So first of all, why we are doing EDA? If the first question is why, where we use it, right? So I'll tell you the life cycle of a ML model, ML product for that matter, right? Machine learning AI product. Where does this data analysis fit in? And data analysis part, where which I also call this. These days, you'll find you know, fresh friendly job. You find most opportunities in this sort of the domain. People needs fresher to do the data analysis. So analyst this analyst. So mostly in the in terms of the numbers, in terms of even the careers, right? So engineers and non-engineers also would be preferred in this job role, data analyst. So I'll show you where does it fit actually, okay, in the big picture. And okay, then I share some, you know, how important is it in today's time to have those analytical skills to be employable, to be employable, right? Because colleges are not going through these skills, and in industries, they are one of the most employable skills, right? Now, thing is, you have creating a ML model, machine learning model, AI model, whatsoever, or for that matter, I'll just put the data science. You're doing any data science project. So data science is like, of course, sort of very science things, right? So that's why I'm putting like the engineering side, ML model, AI model, ML model, AI model are like decision engine for that matter, right? So start with what? So there are first part is like getting the data. So data is like I've given to you. Of course, in real world, it's not like that. It's not that easy to get the very relevant data, very clean data. So there is already a team to get that better data. Agree. If it has been so easy, it's not so easy, right? Your data is being taken by the big giants, right? They are doing a lot of tantrums, providing you a lot of services free just to get your data. And when your imported data, when your pictures not uploaded by you, not uploaded by you as in uploaded by a third party. You're not uploading over Instagram. You're not uploading sharing via WhatsApp, right? Yeah. Instead, you're uploading to a LLM directly. So they have to do a lot of tantrums for that to get you know, your own data, your precious data. Like I believe you have seen those Ghibli trend, right? What was exciting about this Ghibli trend or the one by Gemini, Sari trend, right? So people were putting their pictures from their mobile directly from their cell phone, from their device directly to the LLM. It was getting not the, you know, compressed image. It was getting actual image, true or not, and which is very important for the AI. Of course, this is just one way. There are many other ways to get your data. Okay, you can check when you are downloading or installing Instagram. It is there is a section, the data you share with it. Okay, the data you share with it, you would be shocked. It takes your entire data. So Mark Zuckerberg knows you more than you, and that's why AI is getting so powerful these days. That's why you see consumption has increased like anything. True or not? If I see my pattern, you know, you might also see your pattern. You're always buying something. Every day you buy something. But just go to your childhood days or just ask your parents, you know, what they were buying something every day. No, no. So we people are buying something. We're consuming something every day, right? And maybe this is not a free will. This is being enforced upon us and would always be. We'll come to this, but my point was data. So getting the data is a different uh, game altogether. But in industries, we have data engineers for that, and this is altogether different sport. Sport as in with respect to data science, AI. This is a altogether very different career line. You can think of it as well, but choose one thing. And if I need to advise you personally, go for the AI side more. Okay, having more opportunities, right? This is also it's just like creating infrastructure to get the pipeline. If you have to do create electricity, data engineers does create the infrastructure to to supply to facilitate with the water in the dam. So howsoever water goes into the dam, like the channels or something, this is the work of the data engineers. Agree? Then here's comes you got the data, right? First part is what is my data all about? What is a different relation? What does my data says? What is the different relation of different columns? Which column is important for the conclusion? Conclusion here is survived. If you want to create a system model, your model should give the output as the survived or not survived. I would give this details. Say for example, you would give BP, cholesterol, sugar level, this and that, age, gender, smoking, non-smoking, um, Alana Fulana, you are getting a point, right? Etc. Etc. And your model would predict whether the person would develop in the future a heart disease or not, right or not? So these were the columns, and the target column output should be you would develop heart disease or not, right? So this column, develop a heart disease or not, yes or no. This column is important. You need data analysis in data analysis, but you need to know the relation or correlation of this column with different column. Of course, in the raw data you have many columns. In the real world data you have thousand of columns, hundred of columns. So of course you cannot go with the hundred of columns that can impact your performance, model performance, and eventually can take more time to train, to predict, and time is the key, right? So you have to be very efficient. So this all part, what your data says, which column are important, which column is important for the very important for the uh, you know which column, or I can use feature. The technical word is feature. Call if I use column or feature or dimension, all are same, right? Dimension. So it's important for the target column. So this all decision or analysis take parts in this organ in this part of the workflow, right? Well, this is the life cycle of ML1. You can say that. So this part, this organ, this all decision, this analysis take parts, and we'll do this analysis today. And then this readings, this conclusion, this study is being passed to the maybe data scientist or data ML engineers or AI engineers, and they would now have a better depth, your data, and they make model based on this study, research, analysis, right? In Indian startup ecosystem mostly. Uh, I'll leave this part. ML engineer does all the work, right? Or AI engineer or data scientist is expected to do the analytics work as well. Okay, that's why you need to know this thing. Cool, guys. Clear? And then the deployment part. Then the monitoring part and updation part, though those comes afterwards, right? But we are here, analysis part, right? We have to do this thing today. If you say yes, give me a thumbs up, guys. Then I'll tell you why we are doing it. So first, first point, my point was where we fit in the picture in the life cycle of that ML model, ML AI model. We fit here, data analysis part. So why we are doing it? First is you need to know about the data when you're building a model. So model building. Model building as in not fashion model, the ML model or AI model. If you have better idea about your data, you can configure your model likewise, right? You need to know your data to make better model, right? If you don't know your data, you cannot create. You cannot even choose which model you should go for. You have many algorithms. So first is model building. Okay, what they said is important. Then of course, sometimes it's not just model building. Sometimes it's just like analysis and reporting. Like the same, you can do the one with SQL, Excel. Sometimes you do this. Sometimes it's just like uh, analysis only. Your manager just told you, or the company told you that this year we are not having better sales. Maybe you just analyze it and just create a report. Maybe this is the reason. You know, maybe uh, there is a lot of rainfall due to which there is a flooding situation in Mumbai, and that's why you know the sales impacted. Yeah, it can get impacted, right or not? There are multiple reasons. So analysis and reporting, maybe sometimes just for this part, right? Third time, third reason can be sometimes you have to validate assumptions. So you have some assumption about anything, and that can be validated, or you know mm, after analysis only. Assumption can, what sort of assumptions? Simple. In industry, it can be as simple as that, maybe there's an assumption that, Lay's sales is not improving. And the packet of Lay's is like green. And somebody just proposed you the assumption, let's make it purple. And maybe with this in a particular, you know, or maybe let's make it pink. And maybe then the sales can rise by 5% or something. Maybe it would get more popular among the girls. Girls find it, now something is of ours. You're getting my point. Young girls would feel, okay, I want pink lace only. True or not? Sometimes it increases the sale. Trust me. Maybe it doesn't look very scientific. Maybe it is scientific also because colors also trigger your emotions, right or not? You might feel felt it. There are some product which is being launched in pink colors. Even you would see the public transport as well, some, right? So this is assumption. This is assumptions which I made, and you can validate it with respect to the analysis. Take the data, go through it, whether it happens in the past or not, right? So validate assumptions. You agree with this? If you agree, give me a thumbs up. Or if you have your ideas, your thought process, you know, something into it, you can also, put it likewise. Yeah. Maybe some assumptions can be like, during the rainy seasons, the sales of Maggie goes up. People likes to eat Maggie more during rainy seasons. Is it fine? Is it true? Maybe some assumptions, but we can prove it with the data, right or not? I believe the with Maggie is the smell. It's the Maggie masala, which is the USP, right? Now, second more important with respect to your data as well. If you know about the data, you can handle your missing value properly. Handling missing value. So this is mostly about with respect to the feature engineering, handling missing values. So you have missing values in your data. So based on that, you can. taken take a decision that how to replace this, whether you are going to replace it with mean, median, or you are going to replace with the random values, right? You can only tell it with respect to the, if you know about your data. So if you have missing values like very few, you can just take them off. If you have missing values like in abundance, then you cannot take them off. Then you have to come with a scientific decision. Think of it like the Meta. Meta got this data with a lot of investment, a lot of hard work, a lot of it has to develop faith among its user. Agree or not? You are not sharing your data with any XYZ application, any XYZ company, right? Of course, we are sharing data with ChatGPT, Gemini, and this and that. You can see that, but of course, they also had some credibility, na? We are not thinking before sharing, but we are still sharing with the top player, which have some credibility. You are not going to share with any XYZ. Like you're not sharing it with WeChat, a Chinese company. True. Once we are sharing with TikTok. Cool. If yes, give me a thumbs up. So this data is very important. So how to handle the missing value? If there are so many missing value, you have to take a scientific decision. Your company has given you the, you know, sort of the data, and you said, okay, we can replace this value. There are no value in the age column. Let's replace with them 20. Why 20? 20 is a very young age. Maybe those people who have not given their age may be most likely to be in the older age bracket. Oldies. What is a right term for oldies? Uh, Senior citizens, right? Right? Cool. And there are the handling outliers. Outliers I'll show you had showed you in the last class. And dealing outliers is very important. How you deal with the outliers. You cannot just take them off. Some in some cases you can take them off, but it's not like in all the cases you can just uh, ignore the unusual data. You can ignore unusual data in some cases. Say for example, I often give the example. Say for example, you want to know the average family income of a area. So you would not include Elon Musk into it. If Elon Musk lives in that area, you would not include his income because he's an outlier. His income would be in billions dollar. So it can you can get the average income of that area like in $1 billion. Maybe that area is poor, but there is one very rich guy over there. If you have included this rich guy into it and find the average would increase substantially. Agree or not? And that area which you can say that not economically very strong now comes like a millionaire. West Bay. It would look like a West Bay, right? California. But it's not like that. I believe you're getting my point. But in some cases, you need outlier. Here you can ignore the Elon Musk or the outlier. Say, for example, you have images, sort of a chest, lungs scan of chest or lungs scan of many people. And, there are only few. Most of them are healthy because, of course, you don't find uh, usually, cancer cases. But few are like different, few are very eccentric, unusual. So here this outlier is important, right or not, which is unusual. Here, if you ignore that, then you're ignoring the patient. Cool or not? So how to handle outlier? It is also mean these all things can be done by after knowing the data. Data analysis. Data analysis cover encompass these all part. Cool guys. And yeah, before starting anything, tell you one thing that this is an iterative process. EDA is an iterative process and also subjective. EDA as in data analysis is an iterative. What do you mean by that iterative process? The loops are iterative, right? You have to do it again and it can be done again and again, cycles. It's not like you would catch everything at once. No, in real world also. In first cycle, you would get something, and then you feel that, oh no, okay, maybe there were some assumptions I was taking. I need to re-go and do the same thing again. And you would catch something more better, right? It's just like reading a book or going through a movie. When you read a book again, you feel that you missed something in the first go, or your understanding would be very different this time. True or not? The same for EDA. You have to do it again and again. It is never, it's like, once done, solve for all. Okay. So how we would proceed around it. So of course, this is subjective. Analysis, data analysis is I believe is subjective skills. Um, People have different, right? But I give you some sort of what do you call blueprint, how it can be done, right? A standard procedure, SOP. Uh, so it can be like first identify the column. Okay, we'll go with it, and you participate, guys. Numerical, how many numerical columns? How many categorical? How many mixed column? This sort of. So I would not write it, but it's just like identifying different type of columns, right? Column types. So I would say this is column types. Columns types. Other numerical column. What are the categorical column? You know, numerical columns. So it is categorical columns. Third is mixed column, right? You have to tell me what are the numerical columns here. What do you think? Right? Of course, I can check it with Python code as well, but it's not about checking. It's about what you think can be numerical column. Of course, things can be done by the machine, but my point is not just thinking, not just doing with the machine. We should not be that much mechanical. Okay, I believe in the upcoming time, um, when AI would be very strong, that would be time of real time of humanity, right? When you are all the time in thinking, for philosophy, for debates. So, so let's not be mechanical. Let me know what are the numerical columns here, guys. You can DM me. Meanwhile, just let me help with this. What's the help with this? Okay, fine. Age, right? Very good. Others, listening folks. Age, fair, very good, very good. Others. So you can see the age, maybe fair, right? Mostly, these are the numerical columns. And what would be your sort of categorical column? Categorical column, just do not think numerical column would be one which is having numbers. Okay. That's why I just want you to participate into it. So the thing is, what would be the categorical? Categorical as in which represent a category, right? Sometimes it can be, yeah, sometimes it can be, textual. Like gender is a categorical column, male, female. It represents a community, male, female. Uh, Country, nationality can be categorical column, nationality, right? Language can be a categorical column. Passenger class can also be a categorical column, right or not? It looks like number, but it represents a category. If you just look deeply into it, it represents an economic. Agree or not? And so as survive column, which is also a you know categorical column, binary categorical column, right? We'll come to that in stats as well. Uh, Nominal data, and one is ordinal data, one is sort of binary data, right? Nominal is a name, and name is like the noun. It comes from noun. The name, you can say the sex as well. You can say the cabin or embark as well, represent a category, passenger class also, right? There are mix as well. Ticket is sort of a textual as well as numerical, alphanumeric, right? So that is mixed. I believe that makes sense, and we'll move from there, right, folks? Okay, so knowing our data, I believe we know it. Another thing is I'll go with two ways of solving it. Uh, the second part is SOP. What came in the next way after knowing your columns? Univariate analysis. So we'll perform this analysis in two part. One is univariate, second is bivariate. Univariate is taking one column at a time. Univariate is uni means one, right? Unique. You are a unique. You are one and only one, right? Bivariate is taking two columns at a time, seeing their relation, seeing their correlation. So we are moving towards univariate analysis. Univariate analysis. And it's just like taking one column at a time. And the most famous for this is histogram, right? So point is, of course, now I'm assuming that you know some stats, some math, okay? Though we stats will take after this, on the next week, from next week as in from Monday. But I'm assuming you know some stats, okay? So we'll take one column and we'll go into the depth of that column. We'll see the distribution type. We'll see mean, median, range, variance, these all things, dispersion, all the stats things. Let's do it, and then it will make more sense. Okay. If I keep on talking, it looks like very jargonish with respect to the math. So let's take one column, and let's take age, univariate analysis, and I'll take age, a numerical column. This is important as well, right? Let's see how does the what is important about the age. This is the column DFH, right? 891 rows, one column. So I believe there is no null values here. Everybody has given their age properly. If we just put the describe, same describe pandas. This is a pandas function, if you remember, right? See the type. Of course, it would be a series DF because DF is data frame. One column would be series, right? So describe would work. Now you can see this. The count is okay. So there are some null values as well. 740 total, I believe 819 were there, and you have 714. Mean age is 29. So in that crowd, mostly you can say that young people were, mostly were young. The central character of the data was young people. The standard deviation, this is for variance, right? If you need to understand what is the standard deviation, you can feel it. Sometimes average is not the best metric. Agree or not? Say, for example, one guy has scored 0, 0, and 200 in cricket. His average would come nearly about 70, which is a very good average, right? And there is one guy who has scored like, 60, 80, and 70. His average will also be like 70. But what is the difference between this and this guy? Which guy you would rely more, one or two? This is Ishan Kishan. This is like Shubnam Gill. Yeah, folks. First guy, agree or not? what is the thing which is coming to your mind? Because average is same for both. What is this thing you're looking for? Consistency or spread of the innings? These innings are the variance, the spread is so much 0 and 200. There it is less. Standard deviation, variance is less. Standard deviation is the brother, the younger brother of variance. So here you will see the variance is less. Agree or not? If variance is less, that simply means uh, consistency is more, right? Standard deviation tells the same thing. Standard deviation, just a minute. I click on this thing. So, so this is standard deviation. Minimum value of age, maximum value of age makes sense. 50 percentile we discussed earlier. Median 25 percent, 30%. So getting statistical analysis of age, right? Now let me plot this to find the shape of the distribution. So for that also we have seen uh, in the last class, you can plot DF age. I can plot it with pandas as well. We can plot it with mat plot as well, excuse me. Mat plot. I'm using pandas only. Plot find is equal to hist. Let's see. How does it look? Notice the shape. For that, better is I should go with age dot plot find is equal to KD. So KD is just like the shape, getting the shape of it, outer shape of it, right? Outer shape of this. This is KD, right? So this is the shape of this, right? This is shape of this, and it almost look like normal distribution. It looks like almost like normal distribution, bell curve, right? It is looking like bell. In fact, I can even give you the how much skewed it is. Somewhat skewed, not exactly bell curve, not exactly normal distribution. But yesterday I told you, no, there is a function I can quantify. We can quantify this as well. Skew. If it is less than one, which is it is, then you can say that of course it is more near to the normal distribution. If it is more than one, 4, 5, then it is very skewed, and we'll see today, right? So 0.38 almost normal distribution. So I can put mm, this readings here. Right? First, age is almost normally distributed, almost normally distributed. Okay, okay, I'll again show histogram. Right. Here I've plotted histogram with pandas only. Right. I can plot with uh, Seaborn as well. I can plot with Matplotlib as well, which I've shown in the previous classes. But DFH pandas also a plotting function, right? And this is a histogram curve of your age column. Right? It is fine. Shall I proceed? Okay. Okay, I'll wait for some seconds. If it is done, let me know. Okay, now this is KD plot. Okay, kind equal to KD. This is how much it is closer to normal distribution. So you can just say that it is normal. Age is normally distributed. This is my conclusion. Just a minute. With a skew factor also, you can just give the skew factor 0.38 is the skew factor. Right. Second, what more in this I can do? I can see the column information, right? Or how many values are like null values. So we have seen there was 714, total are 819, like df dot shape. Df dot shape. The shape is not 8091. And df age, if I just put info, so there are 714 non-null values. So that simply means rest are null values. I can also do one thing. Df age. Okay, you can get idea about this. 714 non-null. So the rest are null values. Okay, and are there any outliers? Right. So df age dot is null dot sum. So there are 170 null values. If we can see this, right? There are 117 null values. And what percentage they are? If I just need to see, if I just need to do the exact numbers, is null dot sum. What does is null does? Every column it goes true, false, true, false, true, false, true, false. Right, folks? You can mask this as well. You can mask this as well, or you can just put the sum. Right? Sum would, of course, sum what for true only. One, only it would include one, 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 true, true, true. So divide by df df dot shape and 0. 19%, right? Let me multiply with this 100 and let me print it for you. 19% are null values. So you can also put this thing. There are a lot of null values, right? Second, almost 20%. 20% are null values. Cool, guys. Free. What can be the last thing? So what I did for null values, I just check with the info. Pandas function, we have seen it. Or I've check with the is null function, how many they are, and divide by the total rows. This is total rows, right? Now outliers. Let's check whether there are outliers or not. So for that, df age dot plot find is equal to box plot. You can see this. There are some outliers in the data. Very easily we can see that. And we can pass this information. We don't have to do anything, just box plot. Just plot box plot. And you'll find outliers. Now the thing is you can check it manually as well. Your 5-point summary is telling this age as the maximum age. Who are more than this, they're saying that this is outlier because mean age is 29. Can you see this? Mean age is 29. If you remember, median age was coming as 29. Mean age was coming 29. And based on that, it is coming to the conclusion that this can be an outlier, right? We can check this as well. DF, say for example, age is greater than 65. DF, there are these many people who are more than 65 years of age. 70, 80, 76. This is your outlier. So you can just add this thing as well. There are some outliers in the data as well, which, this research, this conclusion would be read by data scientists, ML engineers, right? There are some outliers as well. Outliers as well. Yeah. So guys, if this is okay, I try to go through one column thoroughly. Any question? Everything is fine. Give me a thumbs up. This is what we have done in the class, usual class as well. I just we just apply all of them here, right, folks? If it's a yes, let me know. Then I'll show you some other analysis. Excuse me. Hmm. Do you want a break for 2 3 minutes? Let me know. Okay, I can understand. So let's take a break of 3 minutes. 3 minutes is fine. Right, guys. Okay, folks, I believe it's fine. So you all are back. Okay. Okay, so it's swing slow as well. Right. So we were doing this with the age column. We can do the same with the other column, like the fair. So let's take one more column, like fair with the fair. Let's check this, right? Fair column. Okay. How does the column look like? Right. The same, almost fair bar describe. Describes a method. So 891, there is count. So of course there were unknown null values. Even I'll show you. $32 is the minimum. Mean fare, average fare. Maximum is this. Oh, so there might be some guys. Outlier. Minimum is zero. Some are traveling free. Western division is this. Okay, makes sense. We're getting some idea. Let's just plot it. Then df fare plot line is equal to hist. This is the histogram. It is highly skewed. If I just show you df dot fare kd plot line is equal to kd. You can see this highly skewed. Normal distribution. Of course, numerical data tends to form a normal distribution, but this is very much narrow, not looking like a perfect bell curve. Even I just show the skew factor. It should come in negative. No, not negative, positive, but a big number, more than one. Left is skewed, so positive. Positive, but 4.7, almost like 5. So this is a very skewed data, right? And then I'll show you the outliers or not. So values, null values, even we can check this. Df pair dot is null. Awesome. Zero. Can you see this? Zero. Int64 is coming because numpy usual data type for numbers is int64, right? So there are zero null values. So I can write these things here in this analysis. You can say that there are no null values in fair first. Second, you can put it like this, what was our data is highly skewed. You can say that uh, it the distribution is highly skewed, negatively skewed. Left is skewed. You said that left is skewed to this side. Left is skewed, right? Till then, I believe it is fine. Let's see the outliers. So df pair dot plot find is equal to box. Now you can see this. There are so many outliers. The mean fare is almost like 32, and the one which are more than 100 has been put like outliers. There are few who are just paying more than $400 for the fare, right? Excuse me. Excuse me. Right, guys. Right, guys. Give me a thumbs up. Just a minute. Okay, folks. But there are outliers as well, and we can check them as well. The one greater than 100. Let's check the fare. Fare greater than, say for example, 100. So these are the people we can check, the kind of the fare people are paying, which we are considering outliers. So where is the fare column? There's so many actually. First, there's a fare column 263, 146, 263. So these are the fare columns. So there are some outliers. There are many outliers as well. You can also put in the your analysis. So this is kind of my conclusion, my analysis for this column. Would you like to see the now for categorical column? Some, and this is for the categorical column. So 100 is, I believe, if I think of from 32 to 100, no big difference. It's not a big difference from 32 to 100. If I can go for 250, then make more closer to a big value, right? There are a few people who have paid more than 250. I can definitely call them outliers, or they're very expensive. So I'll look afterwards into this data, specifically 512. What does that represent? And it gives, trust me, very deep idea or insights with respect to the data. Very deep insights with respect to data. So yeah, this is my analysis so far. Right, guys? Let me know. Then we'll move to a categorical data. If you are excited with respect to the categorical data, give me a thumbs up. Yeah, folks. Yeah, folks. Others there in the room, I believe. Interesting. Yeah, right. This is interesting. Okay, then we'll start. Great. I can see some of the thumbs ups. Yes. So now let's take one categorical data. In fact, data. Let's do for that. You can choose anyone, right? Survived, not survived, that one also, or embark for that matter. So let's take the survived. If this column you want to check survived, right? So of course, this is a categorical. You cannot find the mean of that. You cannot find. There is no point of statistical analysis. Mean, the percentile, the maximum, minimum. There are two values, 0 and 1. Survived, whether survived or not survived. So I'll just do the value counts of that. Value counts. So 0 are like 550 almost, not survived, 49. 342 survived. So almost twice people not survived. Right or not? I can just plot it like as well. Dot anything kind bar chart. Yeah. So these many survived. These many not survived. These many survived. Same I can go for embarked. Not much information from there. We can derive embarked. Right. Embarked. There are stations where people are actually embarked over to the Titanic. Let's see what is the value count from where most people deboarded. Southampton. This is the place from where the ship, or what do you call that? Ship only cruising started. 644. There is Queenstown, there is Cherbourg. 644 from there. Even like we can Detroit. Plot, plot, find equal to pi. Yeah. So of course, afterwards you can just put whatsoever we have seen. Labels, this and this, auto PCT. But this is the distribution, right? Of embark column. I believe this is the best thing we can do about it. The categorical column. Now, rest rest is you have to go to each column for do univariate analysis like this. Every column, just take one column, just analyze something, take the analysis and put it in the report form, like I've put in my notebook. Right. After this, rest you can try and explore by yourself. Kind of SOP I've given for univariate analysis. What's next then? Now you would ask the next part. Next part is bivariate analysis. Bivariate analysis. Okay. And at this point, I'll take some few seconds break. Let me know if it is fine to move. If you have any questions, any suggestions as well, they are welcomed. That is welcomed. Or else we'll start. So bivariate analysis is like you are seeing the correlation relation between two columns, right? Bivariate. And it can be numerical, categorical, 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 numerical, numerical. We have seen this in the past classes as well. Numerical, numerical, we have seen the scatter plot. We have drawn a scatter plot, right? Categorical, numerical. We have drawn, bar chart as well. We have drawn pie chart as well for the same, right? And categorical would must will see, right? But for that we use heat map. We have used heat maps. Categorical, categorical. So and contingency table. I'll show that as well. Categorical, categorical. But we primarily not use much, but still will do here because this is sort of a experiment and apply part we have to apply. So I'll show. We'll try to do all sort of bivariate analysis, right? So let me first go for relation between passenger class and survived column. What I'm doing here is I'm just taking two columns together, survived and P class. What is the impact of passenger class on the survived? What do you think? Which class people died more? First class or third class? Which class people would have more better security, better access to the live boats, or what is your point into it? Then we'll this is a validation. This is an assumption, and then we'll validate the assumption with the data. We'll try to deep dive into the data and see. But what is your assumptions? First class passenger would survive more, or of course they would be more influential, having more, you can say that, connections as well, right or not? And yeah, influential more. And you can see that in movies, in that movie as well, there was some royal class into it as well at the time. In this time also, if you go to the UK, you'll get the people linked with the royal class, right? The, excuse me, queens, related to the queen, or related to the government for that matter. So let me show you something with this. First, there is a function we might have not used in the usual class, cross tab, for the probability. T dot cross tab, right? So it give you, conditional probabilities. Okay, we'll see in the stats class. DF survived. No, sorry, it is not coming. I was thinking auto suggest. It will auto suggest DF survive, DF P class. Come on. I just click over that left arrow. So thing is, if you see this contingency table, we call this contingency table. It is giving me the total number not survived, right? From the passenger class 80, from the third passenger class not survived 372. OMG. And survived from the first passenger classes like anything, right? Let's make it more percentage wise, because absolute numbers sometimes do not give a better idea, right? It just give idea. They're numbers, right? Percentage compare things. We can compare things with the percentage. So let me normalize this with column wise. Okay, I'll tell you how. Normalize equal to columns. If my spelling is right, it would work. Yeah, it is working wonder. And then multiply with this 100. Yes, now we can make more better idea of it. Now, what do you mean by column wise when I'm normalizing it? Just check this. What is happening here? I'm not able to control. Yeah. This simply means, if you see here in the first passenger class, right? If there are 100 people, percentage, 37 are not surviving, 62 are surviving, right? In third passenger class, if there are 100 people, 75 are dying, 20 shows in terms of the percentage, simply shows the third passenger class. If you are linked with the third passenger class, if you're in the third passenger class, your chances of survival are very less, 24% percentage, 3:1 ratio. Here it is 62 percentage. Agree or not? In the second passenger class, it is also the same. Right, guys? If it is a right, give me a thumbs up. Just give me a minute. Yes, folks. There was an interruption, but I believe now it's fine. Yeah. So you got it? It is amazing now. Amazing as in it is very intuitive. This PT dot pro step. Okay. Now the thing is, if I need to represent this thing, I can represent this in even heat map. S- right. Heat map. SNS dot heat map. Same data I can present in heat map. Cool or not? And very dark is like very less. As it is light, it is more. Now just try to read it. Third passenger class survival. The chances of survival of a third passenger class is very dark, very less. Almost like third passenger class chances of not survival, very light. That means not survival, very high. First passenger class chances of survival. First passenger class chances of survival are almost like light color. So good, but not survival are almost like to the darker side of the range. So less. Agree or not? You can read this and you find it, uh, I believe, fruitful. The same thing we have to try with others as well. Now the thing is I can show you this. If I normalize it with respect to rows or index, let me show you that as well. Then it would make other sense. So here I normalize with respect to the columns. Let me normalize with respect to the, so this was the number, absolute numbers. Okay. If I normalize with respect to the index, right? I would say index, right? Then what would happen? Then it would happen. Now, what is the analysis of this? What is this conditional probability? What is your take? How do you read this? You would read this like this. If there are 100 people who died, who not survived, 100 people who did not survive, right? Just imagine. Then 70 are from third passenger class. 17, 18 are from second passenger class. And 14 are from first passenger class. Agree? And if there are 100 people who survived, then there are 40 from first passenger class, 25 from there, 34 from there. Now you would say in survive case, the you would say the proportion, the percentage, the ratio is almost same. Is almost, you know, what do you call the same? Equal, right? This is due to the fact that in passenger class third also, the number of the people were very high, right or not? If I just show you the passenger class, the number of the people in passenger class third might be very high. Can you see this? Third, in passenger class third, there were almost like 500. In one and second, almost like same. Numbers are same. That's why in the survival, right, percentage wise. But when you see the not survive, then you get a better idea that in the not survive also they are more in number. Is it fine, guys? Give me a thumbs up if it is fine. If you're getting what I'm saying, what I'm trying to say. Right, people? Okay. Any questions? Because we are going to repeat the same for others and would explore more. So if you have any questions, let me know. No, thank you. Let's try to explore more. Let's try to deep dive into it. Survived. Let's see the survived versus gender. Or let's put the column name. So I'll do this p dot cross tab df survived. Well, why not name coming survived df gender? What do you think? Which gender would be more likely to survive in this tragedy? In that tragedy, actually, which gender? What is your assumption? Right, of course, this assumption. Then we'll validate it. Yeah, folks, let me know. So let's just slow down now. Because it's not just to cover things, it also to whether you're getting it or not, whether you are able to think or not. So you might feel female would be, right? Folks, give in the chat box your assumptions. Your assumptions. If you're not responding, you're not asking, then it will become super easy for me to cover the course. So don't make it super easy for me to cover the course. I don't want to cover it, just cover it. Right? This is itself a sort of education. Data science, AI is itself education. It's very vast. Of course, it cannot be covered, but covered as in is going through the skimming through the topics, right? The skimming through the topics becomes easier if there are no discussion. More females survived. Yes. And you can see this as well. When I run this, right, you can feel it as well. Uh, Zero, not survived. You see the male are like 468 to 81 females. OMG. And survived. 223 females survived with respect to against 109 males. But in case of the not survived, the people who died, males are dominating like anything, right? Of course, there would be more males than females. If you want to see that, of course, there must be uh, more males there in the ship cruising, which is actually, I believe, is you would feel everywhere in the, you know, whether you go by flight, ship, or anywhere in any space, you'll find more male, right or not? But do you think in the nature also it is like that? Human population, do you find more males are more? I mean, through a study and the thing is research, but it's not like that. Uh, you know, nature is not like 60-40%. There would be 60 male and 40% female. No, I believe nature is like 52-51 male or 49 female. Something more closer to 50-50%. Or vice versa. It is just like there can be more female in nature than male. Something vice versa. Something is study. But on the contrary, in public space, we'll feel the proportion. There's a vast difference in proportion. Okay, cool or not? So there were 600 males almost to 300 females, so twice in the ship. But when they are dying, not dying, not surviving in the what do you call that? What is the right word for the death toll? Easy word for that. Mm, there's an easy word. That tall. Okay, I'm not getting. There's a for that tall. There must be easy word. There, this must have mishappenings. So for that, you can see this 81 female, male are like almost how many times? More than uh, 6 times, 5 or 6 times, right? So numbers were like twice, but it is like 6 times, right? That is, yes, 5, 6 times almost. Yes, so you can feel it, something might be happening over there. Now, uh, this I've created. Let's make it normalize it, right? Rather than numbers, because numbers are absolute, compare it. And I would go with the columns, and let's multiply with 100. So if there are 100 female, right? If there are 100 female, 75% are surviving, 25% not surviving. But in male, if there are 100 male, 81 not surviving, 18 are surviving, only 18 are surviving. This gives a better picture. This gives a better picture, right? Of the analysis. Same. This was with respect to the gender. We can explore more with respect to the area as well, embark as well. I will feel the importance of embark. So this is embark and survive. Survive. Right. So DF PD dot cross tab contingency table. DF survived. Survive. DF embarked. Yes. DF survived. DF embarked. And if I just put normalize is equal to columns. Now you can see this. Let's fill it. If you see Southampton, if there are Southampton, people from Southampton, there are 100 people. You will see 66 not survived, 33 survived. If people are from Cherbourg, survived are more than not survived. If people are not survived are more, survived are more. Okay, Southampton people are more dying. Why so? Why do you think so? Or if you want to check with respect to the station, now see if there are 100 people who are not surviving, if there are 100 people who are not surviving, this 70 comes from Southampton only. Oh, sorry. Passenger, this I put passenger class. What I'm doing here, why put passenger class? Embark. I put embark only. Okay, this I copied with the passenger class. This was okay. I copied this, right? But how it become passenger class? Okay, वो copy that might have not copied actually. The previous copy thing had come. Now, can you see this? I was like shocked. What is happening? Folks, you all are there? Now see, just pay attention, and this is a good analysis. If there are 100 people who are not surviving, 80% are coming from Southend. A good analysis. If there are 100 people who are surviving, 63 from Southampton. What do you mean by not surviving? 80% are coming from Southampton. Why so? Why do you think it is so? Give me a reason. Give me an analysis. Why do you think 80% who are not surviving? Just imagine the situation. You count them, and majority are from a particular city, Southampton. What can be the cause? The reason? Yeah, yeah. People, folks, think over it. Think over it. Think over it. Give me some insight. Give me some reasoning. Give me some idea. You might have some idea. And it's interesting as well. At this moment, we are not engineering it. At this moment, it's just thinking, critical thinking. And thinking is something we all can do. Maybe engineering is not one thing which we all can do. Thinking to we all can do. Right, folks? Just on it. Waiting for your response. Meanwhile, let me address this as well. Very important to get. Okay. Bad at survival. They choose, yes, that can be they choose passenger class three. Yo, good, 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 good. Bad at survival. How can you quantify bad survival? If we have this data only. But the thing is, which you are assumption. The what's your assumption you have, you can validate as well. Okay. They must be from passenger class three. Good, good, good. That is can be acceptable. Rest, we have to, of course, go the data. We have to, you know, go about it, prove it, validate it. Just thinking something, and then so let's try to see. If you say maybe they might be mostly from passenger class three, maybe mostly are male, right or not? Because male are dying more. Maybe from the people who just boarded from Southampton, mostly from passenger class three, mostly from male. That can be the situation, right or not? If you agree with this. Sorry, survival equal to one. No, zero. I just want to check the people hmm, who survived. They no, not survived. Right. Okay. What I'm doing, I'm just want to check Southampton, right? Embark. I forgot the premise. Premise is I just want to check these people. Who are these people? Mostly, right? So these are Southampton people. Now let's see their distribution, whether they are male in majority, yes. But majority can also survive more, no? Why they are dying more? If there are people, known from one particular city, they can just take the lifeboats, right? All of them can take the lifeboats, right or not? Hmm. So if I just want to check their maybe which column you want to check, passenger class of them, and then its value count. This data, the value count of this. Yes. Now you can check some ideas from Southampton. Mostly people are into the third passenger class. True or not? And I can also check the gender of this data. So this was assumption and we can validate that as well. Let's check the gender of passenger class survive. Southampton people. Mostly are male. Twice are male. The one who devoted from Southampton. Twice are male and twice, almost thrice are in. Their sum is also less than. Passenger class 1 and passenger class 2 is less than the passenger class 3. In fact, from this city, very few are into the passenger class 1 and almost twice, thrice are into the passenger class 3rd. That can be the reason. True? You agree? So if they all may be in the same passenger class or same economic strata, then their chances of survival had been very higher. Agree or not? Even in that movie also, they boarded from the same station, but about very different economic strata. Uh, One was from the royal background. The guy was orphan, I believe, was not doing anything, right? What is the right word for them? I don't know in English what is the right word, but homeless kind of person, right? True. If that makes sense, give me a thumbs up. Then we'll see more. We'll deep dive more into the stuff. We'll see the people who are surviving more. What is their age? What is the what is the relation between survived and age, right? And of course, in this, we all have assumptions. You can make assumptions. Anyone can make assumption. Then the things come up with data, right? And of course, data is also not absolute. Getting absolute data, getting right data is important then, right or not? If you've been given a rigged data or incomplete data, then you can have an invalid assumption as well. Agree or not? And this can be proven as well, right? Your model can be very much biased as well. So that's why, that's why Grok is very famous for analysis. That's make Grok very powerful for analysis. It can catch the public sentiment. It has the Twitter data, legitimate Twitter data. That's why for some analysis, I would even go for, for some work for analysis, not for analysis, for research. Gemini is amazing, like anything. It has Google data, and for rest work, ChatGPT is the king. Cool. What's on me to do? Okay. Now I just want to check for survived and age. Let me check this. Now survived age is a numerical column, right? From the time being, we were just seeing sort of categorical column. Now one is categorical, survived, one is numerical. Now I cannot just go with a contingency table, this pd.cross tab. I would use sort of a KD plot histogram, something like that. So let me check this thing. I want survived and age, sort of a age of survived people. So DF, let me put survived equal to yes, the people who are survived. These are the people. Let me mask this data. Right. And now I'll go for their age and then I'll plot it. Right. Say for example, I will go there. Age plot find is equal to KD. Yeah. So this is the distribution of age of the survived, right? Let me label it as well. So label is equal to survived. Get the answer in just few minutes. But just below it, I'll draw. The thing is, there is a problem copying this thing in Mac. In fact, the people who are used to Windows now will understand this. Windows or Linux, right? Mostly Windows. Yeah. Uh, so orange one is not survived. Blue one is survived. Let's try to analyze this chart, this graph. Who survive more? Who not survive more? Right. When this age bracket, of course, this age bracket was very less. From this age bracket, 0 to something, right? Which are like small children, small children. The blue one is dominating, right? Very small children. The blue one is dominating. That they are surviving more. Dominating as in you can see here probability density. Here it is the number. Their area would give the numbers. So the blue one would have more area under the curve, right? So you can say that survived is dominating. So children are surviving more than not surviving, right? And this region, almost like the most young people, not surviving is dominating. Orange one is dominating. So in this age bracket, people are more likely to die. Maybe they are more into the rescuing other people, and it is maybe at that point they were not able to pause the danger because sea was silent. In fact, in the night, if you have been into the sea looks like very silent. You cannot actually feel, though it is very cold, of course you cannot feel until the you can touch the water or something like that, and it is so dark that nothing looks. So they might not able to gauge that the help would come in some time, or maybe the things will get so worse. So earlier just let the kids and the oldies, senior citizens go there. So the youth you'll find more are like in this age bracket, not surviving, is dominating. And this is also like the young people, like 25 to something, less than 30. Can you see blue is dominating this age bracket? I need a different color, rather than different shade of color. This is again almost the same. This region, you can see the blue is dominating. Why so? Survived. They are also like young. This age is also a young age almost. But this age is dominating here. Contrary to our belief, survived is dominating somewhat. What do you think? What can be the reason? Or how can we validate this thing? Yeah, folks. Okay, let's see. I believe that must be due to the age of Passenger class, what? Maybe these people represent passenger class one. Let's see the average age of passenger class one, right? I would say DFP class equal to one. Their age might become closer to this average age. Let's see their average age. This is the people passenger class one. If I take their age and if I take their mean, it might be near that 40 something, C38, right or not? Maybe this represent those people from the passenger class one, mostly, due to which they are surviving more. Agree? So yeah, I believe most of the analysis by univariate analysis is done. Now we can see something more into it. Deep dive into some columns, some data cleaning stuff more. If you want, let me know in the chat box. I'll wait for some minutes. If this is fine, we can of course there are more insights from it. Trust me, this is just tip of iceberg. As we keep on proceeding, iterating the thing, there would be many things can come out of it. Shall we proceed? If it is fine till here, give me a thumbs up and then we'll move. Or you want a break of 3 minutes? Okay, then we'll do it. Right. Now the thing is there are some columns which are not being given due importance, like sibling, spouse, parent, child. And there were one column, like if you have seen that 512, when the, you know, ticket size, when somebody got the fare of 512, then something just caught my attention. If you have thought over it, 512. If you just see this, observe this thing. Observation is a great skill. Observing thing, thinking over it, curiosity is a great skill. 512. See the ticket size, ticket name. See the ticket name. Don't you think it represents the same ticket? Maybe they are same family. They got one ticket only. 512. This. Again the same ticket. Same ticket. How they are getting the same ticket? Maybe that fare is not individual fare. Now I can come to the conclusion fare is not individual fare. Right or not? This might be a family fare. If you agree with this, give me a thumbs up. Mhm. Okay, let me show you what I'm thinking of. Let's see the family. From there, my point is family. And with this, we can cover many things, family size or something like that. Let's try to gauge that family size. How many people are in family and what is the family size? And with this, we can analyze few more things, right? Say, for example, DF. What was the column name? Sibling spouse. Not value. Let's see how many sort of that sibling spouse are there. Zero are like this. There are five people are like they're having a sibling of five. Some are like having a sibling, eight sibling. So this will look like a big family. A family which is having eight siblings would be a big family, and there are seven like this. Let me see this family, right? To give us some, some insight. Sibling, spouse, equal to 8. 8. Let's see which family is this. TF. How, how many people are like this having 8 sibling? So this family, just check this family. Ticket is same, right or not? Plus family name is also same. Sage, 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 Sage. So this represents a single family. And the entire family got one ticket. So this is not a $69 is not a ticket price. It's not an individual ticket price. It is a collective ticket price. So our assumptions earlier, which was like, you know, maybe a single ticket is somewhat is got very different this time. Right, folks? If you agree with this, let me know. Ticket and the family name also. Mhm. Right. Now, my question to you first. Just simple. Uh, what can be the family size of this guy? What can be the family size of this guy? What is the family size of this guy? Then we'll analyze further. Yes, folks. If I need to create a column of family size, what do you think? 8 or 10 or 11? 8 is this. 2 are parent child, right or not? And one, this guy should be there, no? This guy is having 8 sibling, 2 parent child, and one including him. Say for example, he's having 8 brothers and sisters, 2 parent, and one himself, 11. So there should be 11 people of the same ticket, carrying the same ticket, right? Let me check if there are 11 people or not. First of all, how many there are? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7. There are 7 only. DF, let me check the ticket. DF ticket is equal to this. There are 7 only. How I can get 11? Where are those 11? Should I check with the name? DF name, which is the series.str dot contains sage. Let me mask it here. 1, 2, 3, 4, 5, 6, 7, 8. Still I went to 8 only. Why does not come here? 1, 2, 3, 4. This is coming 7. Now I got 8. Okay, ticket is different for this. Segesar. Segesar is different. Segesar is different. So yeah, it includes Segesar. So what is your take? Why they're not 11? And the reason is there are 7 members. Actually, if you can see, I have given you only training data. There is also test data. I have given you test data. If you remember, test data. We generally divide our data into training and test. Train is to train the ML model. Test is to test how the model is performing. So I need to concat that data as well. Then it will make more sense, right? Mm. So why I'm doing this? So you can get an idea that maybe the assumptions we were doing so far was not with the complete data. And that's why I told this is an iterative process. So this is your test data, 418 rows and 11 columns. Now the thing is, I would df is equal to pt dot concat df comma df. Now df dot shape. If you check, 891 was earlier, 418 is this. So I believe it would get changed 1309. Now it got concatenated df, right? Now I'll show you that ticket. Ticket. Oh, just a minute. Just a ticket wala thing. Let me now let me run this here. It would be 11. Same ticket. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Yes, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right or not, guys? So this was the reason. Cool. Now this is your entire data. This is our entire data. Now if I need to create a individual fair column, let me draw that. That would be, or I can just first create a family. Let me just show you df fair, right? Divide by df dot sibling spouse plus df parent child plus 1. Yes, this is our individual fair column, right? Now if I show you my df, you'll see one more column called edit, individual fair. And you can even plot that df box, right? So this is now your individual fare, but still you can file in individual fare also. There's one guy who got 512, who gives ticket of, who take a ticket of 512. That simply means an outlier, very outlier, out, rightly outlier. Okay. And if you want to compare the fair and individual fair, you can also do that. Like DF uh, so fair. You can take their description side by side, right? Mean family fare was this. Mean individual fare is 20. Maximum is same. Minimum is 0, 0, might be same. But you can see this standard deviation here was this much. Here it is less. Mean is $20, right? You can feel it. Median is also 14.8. So this is the difference between individual fare and fare. So yeah, you might have felt it. Same, you can create a family size, right? There can be one column for family size as well. If which can be DF um, sibling spouse plus DF parent child plus 1 plus 1, right? There would be one more column, family size. Now almost it is done. Now you can reanalyze, analyze more, go into the stuff like create different big family, small family, and this, and then go for the analysis like based on the family size, who survive more, big family survive more, small family survive more, and this and that, right? So almost it is done. Some part I can show you tomorrow. Okay, guys, I would not stretch it further, else it can be overwhelming. Okay, folks, so that's all from my side. Yesterday I shared with the team two task assignment. Okay, try to go through them. I'll share more from the previous things we have covered, right? Your assignment, the task assignment you have to do. Okay, for you. So it's been created by me. You can go through them, and yeah, for your practice only. 18, today's 18, not 16, never more, right? Anything I can name for your batch? Okay, no, 16 number is okay. I have no idea of your batch as well. The name, actually. So that's all from my side, guys. Bye bye. Take care. Enjoy. See you tomorrow or next day. Bye bye. Go through the stuff. Yeah, whatsoever. I'll share the file with the team and all, and plus the assignment. Okay. Take care, everyone. See you.